Okay, so we are going to get started and finish up 9.1 is where we were finding the composition of two functions, where it's where we were plugging into one function, getting a solution, and then using that solution to plug into the other function. Okay, so we are on number 4. And our two functions are f of x equals x plus 25 and g of x equals x minus 25. So these are going to want us to find it both ways. So first of all, we're going to find f of g of x. So remember, just like the last lesson or the first part of this lesson, whatever is in this position is what you're finding first. So I'm finding g of x. So in other words, when I come up here, it tells me exactly what g of x is, doesn't it? That's what that equal sign means. G of x is. So this is the g of x function, right? So I'm not even replacing anything, or I guess I'm replacing the x with an x. So it's just x minus 25. And I can't simplify that any, right? I can't put those together. So I'm just done with that first part. So what was always the next step? You just bring down this f. And what do you find f of? You put your last solution here. So I'm putting the x minus 25 in the parentheses, which tells me to go to my f function. And wherever I see an x, I'm going to write this, x minus 25. So right off the bat, I see the x. So instead of x, I replace it with x minus 25. And then finish the function, so plus 25. And what happens when you combine the 25 and the negative 25? Right, it's just 0. They cancel each other out, so all you're left with is x. So that's that final answer. Then, this one has 4 parts. I'm going to find it the other way around. So I found f of g. Now I'm going to find g of f of x. So this time, I'm starting off with f of x. And once again, it tells me what f of x is. F of x is x plus 25. And I can't do anything else with that, right? I can't put the x and the 25 together because they're not like terms. So I move to the second part. This time I'm bringing down g. My last solution was x plus 25, so that's what comes in here. So this tells me to go to my g function and replace its x with what's in the parentheses. So instead of x, I write x plus 25, bring down the minus 25. And just like the first one, the plus 25 minus 25 knocks each other out, and all you're left with is x. Now, the last two things that you're going to want to, it's going to ask you to do is to find the domain of each of these. Okay, so the domain of each of these, you look in 2 spots, because remember when you're finding the domain, which is what your x values can be, you're actually looking for restrictions on the domain, what x cannot be. Because then once you find what x cannot be, it can be everything else. You're looking in 2 spots when you're using composition of functions for the restriction. Obviously, you look at your final answer. The other place that you have to look is what you plugged in. So this answer also, you're looking in those 2 spots for for restrictions. Now, remember, the only restriction that we've dealt with so far is fractions that have x's in your denominators, because you don't want the denominator to be 0, right? I don't have that in either of those spots. Okay, so the domain is going to be all real numbers. It's just that in this section, it wants you to write that in interval notation. What interval notation is it's going to have an opening symbol and a closing symbol. And you think about that as coming off the number line. So if I'm thinking about the number line, just the like number line, this arrow means that number line goes forever and ever and ever. That sideways 8 is an infinity symbol. So it goes forever to positive infinity that way and forever to negative infinity that way. Now, when I'm talking about all the real numbers on the number line, I'm talking about every single number on the number line, all the way from the left side to the right side, everything, which means from negative infinity to positive infinities is written like that. Infinities always have parentheses around them. They don't ever have brackets around them. So the domain of this one, again, I look in 2 spots. I look at my final answer for restriction and what I plugged in to get that. So again, no fractions with x's in the denominators. So it is also negative infinity to positive infinity, its domain. Right? Number 5. F of x is x plus 4. G of x is 2x squared minus 7x minus 4. So we're going to find f of g of x. So same thing. Starting here. G of x is all that. 2x squared minus 7x minus 4. And I can't simplify that, right? So I'm done with the first part, which means bring down your f. And in the parentheses goes what? Whatever your last solution was. It's just your last solution was all that. So in parentheses, 2x squared minus 7x minus 4. So that tells me to go to f. What am I going to put instead of this x? All that, right? You replace the x with whatever's in parentheses. So instead of x, I've got 2x squared minus 7x minus 4. So that replaces the x plus 4. And what happens at the end here? Right, zeroes out. So all I'm left with is 2x squared minus 7x. Now this one, I ain't gonna do it the other way around, but this one, like it should, asks me to go ahead and name the domain of this one before I find g of f over there. So remember, there's 2 places to look for restrictions when you're finding domain, the final answer and what you plugged in to get the final answer. Are there any restrictions here? No, there's no fractions with x's in the denominator. So that domain is Again, negative infinity to positive infinity. Now I'm going to find it the other way around. So now I'm going to do g of f of x. I don't have room, so I'm just going to erase this. So now I'm doing g of f and finding its domain. So f of x is what I'm starting with. So f of x is x plus 4. So done with the first part, drop down my g. What goes in parentheses? Your last part. So x plus 4. And here's where this one gets complicated. Because I'm going to g, and everywhere I see an x, I'm going to replace it with x plus 4. So I have 2. Instead of x, I have x plus 4 squared minus 7. Instead of x, x plus 4 minus 4. Now, I've got to simplify this, and the first thing I got to do to simplify this is take care of that exponent. What does x plus 4 squared mean? It means x plus 4 times x plus 4. You don't just square each of those numbers. You square the whole thing. Okay? So I'm actually going to write that out over here because I'm going to have to FOIL that. Right? You'll see that once you write it out. X plus 4 squared really means that. So if I'm going to FOIL this, x times x, x squared. Your outer, x times positive 4 is positive 4x. Your inner is another positive 4x. And your last, positive 4 times positive 4 is positive 16. Clean it up. Those x's together. So I really now have x squared, 4 gives me 8x. Plus 16. So where does this go? Why did I do all this? Because that's what this is right here, right? So now the only thing I'm going to do is just rewrite this whole thing, but instead of writing x plus 4 squared, I'm going to write what x plus 4 squared is, which is that. So I'll have 2 x squared plus 8x plus 16. So that took care of that. Now I'm just dropping the rest down. So now, after, I need to get rid of these parentheses. So I'm distributing the 2 to this one and the negative 7 to that one. So 2 times x squared, 2x squared, plus 2 times 8. That gives me 16x plus 2 times 16, which is 32. So that gets rid of those parentheses. Now I'm going to do the same thing with the next. I'm going to distribute this negative 7. Negative 7x. Negative 7 times positive 4 is negative 28. And then drop down the minus 4. So clean it up. This is my only squared term, so I'll just bring it down. I can put this x and this x in the same basket. So 6 minus 7, I actually have 9 x's. And when you put the rest together, they're going to zero out, right? Because you've got 32 minus 28, which is 4. But then you have minus 4. So that's just gone. So all you're left with is this, 2x squared plus 9x. And its domain, again, where are you looking? Final answer, and also what you plugged in to get that answer. So any restrictions here? No, there's no fractions, so no restrictions. So again, your domain is negative infinity to positive infinity. Last one. F of x is 5 over 1 minus 4x. And g of x is 1 over x. First finding, f of g of x. First, g of x. So g of x is 1 over x. Now with that part, put down your f. F of your last answer, 1 over x. Here's where it gets complicated, right? Where are you going? You're going to f. So here's where I'm going. What am I going to put in place of this x? 1 over x. So let's see what that looks like. I have 5 over 1 minus 4 times 1 over x. So I am going to multiply that. So now I have 5 over, just bring down that 1. Now, when you multiply fractions, remember, multiplying fractions is the easy math to do with fractions because I don't have to worry about common denominators or anything like that, right? You only have to have common denominators if you're adding and subtracting fractions. If you're multiplying fractions, you just multiply the top numbers together and the bottom numbers together. This one is a fraction because if it's a whole number, it's just over 1. So when I multiply the top, I'm going to have minus 4. When I multiply the bottom, of x. Now, this essentially is the answer. It's just not going to, MATLAB's not going to let you type it in like that because it's too complicated. By too complicated, I'm saying that you don't want to have a fraction inside of a fraction. So how are we going to fix that? Now, remember, what is the one number that you can multiply anything by without changing the amount of it? 1, right? Doesn't matter what you multiply by 1. If it's 10 million, if you multiply that times 1, it's still 10 million. So the only thing I can multiply this fraction by is 1 without changing it. But there's all different ways to write the number 1. If you have a number that's the same in the top and the bottom, isn't that 1? What's 5 over 5? What's a million over a million? So I'm going to multiply this by 1. It's just going to be a fancy 1 because my goal in this step is to cancel out this denominator so that I don't have a fraction within my fraction. So whatever this denominator is, that's going to be your fancy 1. I'm going to multiply the top and the bottom by x over x. I have to do it in the top and the bottom because that's what makes it 1. Right? X over x is just 1. So I'm just multiplying this fraction times 1, which means I'm not changing the amount of it. I'm just going to write it in a different way. So let's see why I do this. Let's see. What do I get when I multiply the top? 5x. of these guys. So x times 1 is x. Here's why you did it. What happens when you multiply this x times this fraction? Cancels out that x. So I just am left with -4. MATLAB will like this fraction because there's not a fraction within a fraction. So that is your final answer. Now, the domain. Okay, and if you have the printout, you'll see that the domain is a multiple choice part of the question. Remember, I'm looking for restrictions in 2 spots. The final answer, which has a restriction, right? Because I've got an x in my denominator, and what you plugged in, which actually has another restriction because it also has an x in the denominator. So I'm going to have 2 restrictions in this domain. So the 2 things that can't equal 0 are x can't equal 0 and x minus 4 can't equal 0. That one's just already solved for me. I don't have to work with that one, right? X can't equal 0. This one just has one simple step to get rid of the -4. Need to add 4 to find out that x also can't equal 4. Because if x is 0, I would be stopped right here in the process, right? I wouldn't be able to go any further because you can't have 1 over 0. But if x is 4, then that would have been undefined. So that's why there's 2 restrictions. X can't be 0 and x can't be 4. Now, once in an interval notation, again, it is multiple choice. So let's think about the number line again with those 2 restrictions on it. So there's infinity, there's negative infinity. Every number from negative infinity to positive infinity is good, except 0 and 4. So in my interval notation, I want to show this. I want to show that all of this is good. So what is that from where that one would start at negative infinity and then go to what? 0. I put a parenthesis around the 0. That means do not include that number. That's what a parenthesis is telling you. This number is not included. Now there's a little symbol. This means in union with or and. Because I also want to show that this part of the number line is good. So what is the start of this one? 0, what's the end of it? There you go. And I also want to show that this is good. So and, another and, starting at 4 and then going forever to infinity. So that's its domain. That shows all the numbers on the number line from negative infinity to positive infinity, except 0 and 4. Sorry. So there's half the problem, right? Because all we've done so far is f of g and its domain. So now what are we doing? G of f and its domain. Okay, G of f. So first things first, f of x. Which is 5 over 1 minus 4x. Done with that first part. Dropping down my g. What are you finding g of? Right. Right. 5 over 1 minus 4x. So I'm going to g. So instead of an x in in my denominator is going to be 5 over 1 minus 4x, right? That's going to be replacing it. So I have 1 over. Replace the x with the parentheses. So 5 over 1 minus 4x. Essentially, again, that's the answer. MATLAB doesn't like that because I have a fraction in my fraction. Now, remember earlier, I've got to multiply this fraction, the same thing on top and bottom, so I'm only multiplying it times 1. It's just going to be a fancy form of 1. What is the denominator that I'm trying to cancel? 1 minus 4x. That's going to be your fancy 1. 1 minus 4x. And I do it on top and bottom, right? Because that's just a 1. So up top, what's 1 times that? 1 doesn't change it, right? So 1 minus 4x. This is why we use the 1 minus 4x right here, right? Boom, boom. So what are you left with in your denominator? Just a 5. That's your final answer. Now, working on the domain. Now, I look in 2 spots. The final answer and what I plugged in. This is a fraction, but there's not an x in the denominator of this fraction, which means it doesn't make a restriction, right? The denominator of this fraction is always going to be 5. There's not an x down there to change it. So there's no restriction from the final answer, but there is a restriction in this part, right? Because it does have an x in its denominator. So I need to find that restriction. So let's see, 1 minus 4x can't equal 0. So solving for x, I need to get rid of the 1, so I'll subtract the 1 off both sides. So now I've got negative 4x can't equal 0 minus 1 is negative 1. Divide by negative 4. To cancel that negative 4, so x cannot equal negative over negative, so it can't equal positive 1/4. So 1/4 is the only restriction here. So again, I feel like it's easier to see it on the number line and then use that number line to show your interval notation. The only number I care about is 1/4. That's my only restriction. So there's going to be an open hole there. But I do want to show that x can be any other number on this entire number line except 1/4. So all of this side of it. So that would be from negative infinity to 1/4. And all of this side of it's okay. So that would be 1/4 to infinity. $9.2. All right, 9.2 is finding inverse function. And when you're finding the inverse, that means you are inverting the x and the y. You are interchanging them. So the first 2 problems are not bad at all. Actually, this section is not near as bad as this. The first problem just gives you a list of points and says find the inverse of the relation. So my points are negative 9, 5, negative 7, negative 1, negative 5, negative 3, and 5, negative 5. So those are 4 points or 4 ordered pairs. And remember, each ordered pair has an x coordinate and a y coordinate. So if I'm going to find the inverse of this relation, that just means rewrite all those points and flip-flop your x and y in. That's it. So this one would be 5 in the x spot, -9 in the y spot. Now, when you're typing this in MATLAB, it does say separate your ordered pairs with a comma. And if you don't, it's going to mark it wrong. So comma, flip-flop, -1, -7, comma, flip-flop, -3, -5, comma, and flip-flop, -5, +5. So that's all you do on number 1. Since it's just points, you are just inverting the x and the y's at those points. On number 2, same idea. It's just that it gives you an equation and asks for the inverse. So x to the third y equals -5. So it just wants what the inverse equation would be, which just means, right, y to the third x equals -5. That's all you're doing there. Now, on 3, 4, 5, and 6, it's going to give you a picture of a relation or a function and ask you if that function is what's called one-to-one, because one-to-one functions are the functions that have inverses. Now, remember how we were looking at graphs telling whether or not they were functions? We used the vertical line test, right? And if the vertical line only touched the graph one time, then it was a function. Well, to tell if a function is a one-to-one relationship function, it has to pass the horizontal line test. The horizontal lines are the ones that go this way, right? So I'm going to draw all 4 of them up here. It's the same rules though. The horizontal line can only touch the function one time in order for it to be a one-to-one relationship. I'm going to draw numbers 3, 4, 5, and 6 all up here at the same time because I think that makes it clearer, the yes and no's. All right, number 3, like that. Number 4. That. Like that. Six looks somewhat like that. Okay, talking about the horizontal line test to see if these are one-to-one functions or not. So this one, I'm drawing a horizontal line on it. No matter where I draw a horizontal line, I'm not ever going to touch that green graph more than one time, right? Doesn't matter where I put it. I'm only touching it one time. So this one is a one-to-one function, yes. What about this one though? If I draw that horizontal line right here, how many times did I touch that upside down U? 2 times. Doesn't pass it. So this one is not a one-to-one function. Same with this one. Touches it twice. Not a one-to-one function. But this one, doesn't matter where you put that horizontal line, you're not ever going to touch that green by looking at the graph whether it's a one-to-one function or not. Now, the reason we do this is because the only functions that have inverses are one-to-one functions. The rest of this section is determining if a function is one-to-one, and if it is, find its inverse. So let's look at number 7. Oh, actually, let me write the steps up here first that you're going to use to find the inverse. Right, so there's the 3 steps. Okay, a lot of times when you see a function written out, instead of saying y equals 3x plus 1, it'll say f of x equals 3x plus 1. But remember, f of x and y are the same exact thing. So the first thing you're going to do is just rewrite the function and replace the f of x with a y. Then the second step, this is the inverse part. That's when you flip-flop the x and y. Then the last step is to solve for that new y. So now let's look at number 7. F of x equals x plus 8. So my first step is to just simply rewrite this, but replace the f of x and write it as y equals x plus 8. Right, now you'll do your inverse part. My inverse part is to flip-flop these. So now you have x equals y plus 8. So now that you've put your y in a new spot, that's your last step, is to get that new y by itself. So get rid of whatever's with your y. So I'm getting rid of plus 8 with a minus 8. So there's my new y all by itself. And on the other side, I can't put those together, right? So x minus 8 is the inverse. Now, when you're looking at the sheet, it's going to say f to the negative 1 of x equals, there's your answer. This right here means inverse. So here was the original function. It's inverse, which is what you just found. So that's where you put the x minus 8. Number 8. F of x equals 4x minus 6. Right? Rewrite your function, replacing f of x with a y. So this also says y equals 4x minus 6. Now flip-flop them. So x equals 4y minus 6. Now get your new y by itself. Get rid of minus 6 with a plus 6. So on the left, I've got x plus 6 equals, I still have 4y. So I got to get rid of that 4. Since it's hooked on, I'm going to divide by it. So those 4's cancel. There's my y all by itself. MATLAB is actually going to let you leave this one just like that fraction right there. So x plus 6 over 4 is your inverse. Oh, I've been skipping a step. So on these problems, the first thing it asks you is the function 1-to-1? Because if the answer is no, then you don't have to find the inverse. Okay, but both of these, if you type them into your y equals, if I went in my y equals, and I'll just do this one, 4x minus 6, and graph it, right? That's what I need to see is the graph of it to see if it passes the horizontal line test. And both of those will. Both of those are both lines like this. So they're both going to pass the horizontal line test. So part of those answers that I skipped were yes, they are both 1-to-1. They both pass the horizontal line test. Okay, so does number 9. They're all going to pass it, by the way. F of x equals 3 over x plus 9. Ooh, that's great. All right, I'm going to rewrite first. Y equals 3 over x plus 9. Flip-flop. So x equals 3 over y plus 9. Now here's the complicated part of this one because now I'm trying to get this y by itself. If what you're solving for is in the denominator of a fraction, that's not good. I got to get this y by itself. The way that I make it not be in the denominator of a fraction is I'm just going to get rid of the fraction altogether, which means I want to cancel this. Means I got to put it up top. If I do it on the right side, it's an equation, right? Whatever you do to the right, you got to do it to the left. So let's see what I got. Cancels here. I just got the 3. Now this x does go to both of these. X times y is xy plus x times 9 is 9x. Here's what I want by itself. Get rid of this. So minus 9x on both sides. Almost there. I still have xy equals. Can't put those together. So I have 3 minus 9x. The last thing I need to get rid of is that x that's hooked on, which means I'm going to divide by it. I'm going to divide everything on both sides by x. So there's my y all by itself like I want. I can't do anything with 3 over x. Minus, but these x's do cancel, right? So I'm just left with 3 over x minus 9. All right, 3 more, but they're not as complicated as this one. Number 10, f of x equals x cubed minus 5. So the first step is just to rewrite it as y equals x cubed minus 5. Then I'm going to solve, oh, excuse me, I got to interchange flip-flop first. So x equals y to the third minus 5. Solve for your new y. Get rid of that minus 5 with a plus 5. Why am I doing plus 5? Because it's the opposite of minus 5. That's how you cancel things. So here I've got x plus 5 equals, I still have y cubed or y to the third power. So this is why I said this at this point. We've been doing it 100 times. The opposite of -5 is +5. That's how you cancel stuff. So I need to cancel out a cubed power. The opposite of raising something to the third power is taking the third root. These two things are opposite operations. Those knock each other out, just like minus knocks out plus. If I take the cube root of that side, I got to take the cube root of this side. So that cancels that. There's your y all by itself. Can't simplify that. So you just got the cube root of x plus 5. Now, so this is what you're typing in. Okay. In MATLAB, when you're typing in a cube root, you know, down at the bottom, it's got two things. That's a square root. Then it also has that button. You want to choose this button, right? Because this button will let you put a little 3 right there for a cube root. And then you put the x plus 5 there. Right, 2 more. So this one has this little extra out to the right of it. Here's what this means. Because when you graph this, it's an x squared. So it's going to make a parabola, which does not pass the horizontal line test. Okay, but this says only use the part of the graph that's greater where x is greater than or equal to 0. Well, here's where x is 0 right here. It's saying only use this part of the graph, which does pass the horizontal line test. That's all that that extra out there means. So in other words, you have to find the inverse. All right. Rewrite. Y equals 3x squared plus 2. Flip-flop. X equals 3y squared plus 2. Solve. Get rid of plus 2 with minus 2. So I have x minus 2 equals 3y squared. Get rid of the 3. Took on, so we're going to divide by it. So I still have y squared. On the left, I have this weird looking fraction, x minus 2 over 3. So just like the last one, when I had to get rid of the cube root, I did cube root. So to get rid of squared, I'm going to do square root. So it knocks out the squared. There's my y by itself. All this over here is your answer. Square root, x minus 2 over 3. Last one. F of x equals the square root of x plus 6. Rewrite. Y equals the square root of x plus 6. Flip-flop. X equals the square root of y plus 6. So now we're trying to get this y by itself. I can't do that minus 6 yet because it's trapped under the square root. So you got to get rid of the square root before you can get rid of the plus 6. This is all trapped in there. So these two things are opposite operations, right? I use the square root to knock out my squared. So now I just need to knock out my square root. So I'll do the opposite of it, which is square it. Both sides. So here, I've got x squared. Everybody say hi to Mr. Hopkins.
Guys.
So I have x squared, and then this cancels because they're opposites. Y plus 6. Last step here. Now I can get rid of the plus 6 because it's free. So plus 6 minus 6 cancels. There's your y by itself. X squared minus 6.